So, good day everybody. Again, in continuation of our number base system, we'll be discussing about addition and subtraction of number base. So let's start with base 2. We have add is it 111 plus 101 base 2. You can only add number or subtract or do any board mass of the same base. So 10111. So if you are going to do this, write 111 101. Everything is in base 2. So 1 plus 1, it's our normal 2. So we come here, say 2. Since we are talking in base 2, 2 into 1, remainder is 0. So we write it 0. We carry this 1, we put it here. So 1 plus 1 again, we have our 2. So the same thing we do here, we write our 0, we bring it here. So 1 plus 1 plus 1, this 3. So we come here, we do 3. 2 in 3, 1, remainder 1. So you can write 2 in 0, 2 in 1, 0, remainder 1. So like I said, you're writing like this. So you write this 1 will be this, and this 1 here now will be 1. So that is the final answer. So likewise, if you are doing 1 base 2, maybe you are adding 111 base 2, 1111 base 2. It's about 3 now. So we have 1 plus 1 plus 1. You know it's 3. So you come here, you do your number 3. 2 in 3, 1, remainder 1. You write this remainder 1. You bring this 1, you bring it here. So 1 plus 1 plus 1 plus 1. That is 4. You come here, you do 4. 2 in 4, 2, remainder 0. You write your 0. You carry your 2 here. 2 plus 1 plus 1 plus 1. 2 plus 1, 3, 3 plus 1, 4. 4 plus 1, 5. So you do for 5 also. 5. 2 in 5, 2, remainder 1. So you write your 1, you bring in your 2 here. So 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. So you have 5. So you write your, you can do it again, 5. 2 in 5, since this is the last one, 2 in 5, 1. 2 in 5, 2, remainder 1. 2 in 2, 1, remainder 0. 2 in 1, 0, remainder 1. So you write this from here. So 1, 0, 1. So this is the final answer. In addition, while in subtraction also the same thing. For example, you have 1 2 3 base 4 minus 14 because I've written base 4, I can't write 14 again. 12 base 4. So 3 minus 2, that is, since we are doing minus 3 minus 2, that is 1. It's still within the range of 4. 2 minus 1, 1. Then you have 1, all in base 4. So many if it's addition, 1 2 3 base 4 plus 12 plus 4. Addition. 3 plus 2, 5. You know it's more than 4. So you come here, you write your 5. 4 in 5, 1, remainder 1. You write this remainder, you write it here. You bring this 1, bring it here. 1 plus 2 plus 1, that is 4. And this 4 here again, so you can't write 4. So you are going to write 4 here. 4 in 4, 1, remainder is 0. So you write your 0, you bring 1. So 1 plus 1, 2. 2 is still within 4. So 2, 4. So all this depends on your constant practice. For example, I know in binary number, 1 plus 1, for me, in binary number, if it is in base 2, it is 10. So I can use that here. 1 plus 1, 10, 0, bring 1. 1 plus 1, 10, 0, bring 1. Then I have here, and I know in binary number that if I have 1 plus 1 plus 1, like 3 is going to give me 11. So the same thing. So it depends on how, but this is better for your consistency. If you get used to it, you can advance to this. So this addition and subtraction. And the subtraction can be funny at times when you have, let's go deeper. We have 1 2 3 base 4 minus, let's say the highest is, we can have is 3. No, maybe let's make this one 2 and make this 3 and make this 23. base 4. So you know here now that is 4 minus 3. 2 minus 3. It's impossible. If it is 2 minus 3, it's impossible. So what you are going to do, you borrow 1. Having in mind that when you borrow 1 from here, you are borrowing like 4. It's not your normal 12, because if it is in decimal, you are borrowing like a normal 10. So here you are borrowing 4. 4 plus 2 is 6. So that here now you are borrowing like 4 plus 2. So here is 6. 6 minus 3, you have your 3. And here you have your 1. 1 minus 2 is impossible. So you are borrowing another 1 from here. If you are borrowing your 1, it's not normal 1 you are borrowing 4. So 4 plus 1, 5. 5 plus 2. 5 plus 2. 5 minus 2, sorry, pardon. We give you 3. So you have 33. If it's not clear, if you want to confirm, if you add these two together, you have to get 1 to 2. So let's add it together. 23 base 4. 33 base 4. So 3 plus 3, 6. So you come here, you write your 6. 4 in 6, 1, remainder 2. You put in your 2 down. So you carry this your 1 here. 1 plus 2 plus 3, you have your 6 again. So you can use this also. So since you have your 2, remainder 2, 4, 0, 1. So you have your 2, 1. Base 4. So you are getting this back. Hope it's clear, and if it's not clear, please try to call my attention in the comment segment. So this is all about addition and subtraction. You just need to keep trying questions. There are many questions. You can have 101 plus 110. These are the simple ones. Base 2. So 1. If you add it together, you have 1. You have what is it called 1 again. If you have 1 plus 1, like the method I told you, and 1 plus 1 is 10. In base 2, since you know it's base 2, if they write base 3, be careful of it. So know how to calculate it. For example, I write 101 base 3, 110 base 3. So you know 1 plus 1 is not 10 in base 3. So 1 plus 1 here is 1 plus 0 is what? 1. 0 plus 1 again 1. 1 plus 1 can be 2. Will be 2. Sorry, because it's still within 3. So this addition and subtraction in binary number. The same applies. The same method goes to multiplication and division. Multiplication and division. So if you are doing multiplication, for example, 11 1 base 2 times 1 base 2. All you need to do is write 1 base 2. 1 base 2. So 1 times 1 in base 2 is 1. 1 times 1 1. 1. You know 1 plus 1 in base 2 you have 1. 1 plus 1 in base 2 you have 10. Or you can use the just write 0. Then you carry on 1. 1 plus 1 again in base 2. That is 10. So you have this. And if it is in base 3, 1 base 3 times 1 plus 1 base 3, you have your 1 3. 1 3. So 1 times 1 is 1. 1 and you add it together. 1 plus 1 1. 1 plus 1 in base 3, you have your 2. 3 can still accommodate 2. Then you have your 1 again. So this is in base 3. So this multiplication. While for division also, division is also easy. It depends on what they are given. If you are given, for example, which one have we done before? Which that is let's see anyone that's no, I can't find no one for now. Okay, let's see 204 base 5. We have done this before. Divided by, this is the same thing as 504 and 54 base 10. So divided by, do you have any base 5? No, we don't have any base 5. Or let's say divided by 10 base 2. So the best you can do here, if you have to do anything, is to convert both to base 10. We have converted it here before, 204 base 10 to base 10. So you can just write 54 base 10. And you know that if you convert 10 to base 10 base 2 to base 10, you are going to get what? You are going to get 2 base 10. We have done this before. We have done that also before. 10, if you convert your 10, like right here, to base 2, and it's also here. So when you divide here, you have your 20 what? Sorry. You have your 27 base 10. So if your answer is in base 5, we can later convert 27 base to base 5 or to base 2. So if you convert 27 base 10 to base 2, you write 204. You have 27 because you are converting it to base 5. 5 in 27, 5, remainder 2. 5 in 5, 1, remainder 0. 5 here, 0, remainder 1. So your answer will be 102 base what? Base 5. That is the answer for this. If your answer is in binary, so you have this here already. So all you need to convert your 27 to binary. Then you come here, you write your 27. 2 in 27, 1. 2 in 7, 3, remainder 1. 2 in 23, 2 in 13, 6, remainder 1. 2 in 6, 3, remainder 1, remainder 0, 2 in 3, 1, remainder 1. 2 in 1 is 0, remainder what? 2 in 1, 0, remainder 1. So this will give you 1, 1, 0, 1, 1 base 2. So these two, they are the same thing as this. Because of time, I'm sorry I jam-packed addition, subtraction, multiplication, and division. But if there's any question or assignment, any question bothering our mind, there's opportunity comment below. Please kindly post any related question to it, and justice will be done to it. So thanks very much for watching. So in this episode, we're talking about the complex question, which deals with combining two base numbers like base 2, base 5, base 5, base 10, combining them together. Thanks for listening. Thanks, we really appreciate it.